Hi, my name is Rachit and I am one of the instructors for the 2019 GenWise course, Intuitive Electronics, a problem-solving approach. I'm an electronics engineer and for the last 9 years I've been working on the design of analog circuits for applications like audio codecs, serial interfaces and clocking references. I'm presently taking a break from work to explore my interests in discrete audio electronics and speaker design for niche applications. Through this course, we're trying to introduce electronics to students in a manner that they can visualize and connect with how electricity, electronic components, and circuits work together to serve specific functions. Through experiments and measurements, students will see how quantities like voltage, current, and resistance interact, and they learn physical analogies to help them visualize these interactions. As they incorporate capacitors and inductors into their experiments, they'll learn about electromagnetism, and they'll see how these reactive components change their behavior with change in frequency of the applied signal. They will also learn how the physical properties that they've learnt about can be used via sensors and transducers to measure, detect and respond to changes in their surroundings, like an intrusion detection, change in ambient lighting, or making a passive intercom. Students will also be introduced to operational amplifiers as the fundamental units of systems that can perform mathematical functions. They'll see how specific system behavior can be broken down into these functions. They'll then move on to using their understanding of op-amps to build these mathematical functions in circuits and create games using them, which may be collaborative or competitive and require some kind of a human input. Given that we'll be spending so much time with signals, we'll also take some time out to understand the nature of these signals. Students will see how waveforms can be broken down into simpler constituent signals like sine waves, and they'll see how manipulating the frequency content of these waveforms changes their nature. They'll also build some simple musical instruments and observe the waveforms of the sounds that they produce. And they'll see, for instance, that a note that is 1 octave above another note is actually twice this frequency. We're hoping to cover a lot of ground in this course, and we hope you'll join us.